Today we're going to look at solving quadratic equations using the quadratic formula. The quadratic formula solves equations of the form ax squared plus bx plus c equals 0. So it solves equations in standard form. You should pick out a, b, and c as the coefficients of the x squared term, the x term, and the constant, and use the formula given right here. You'd recognize that this is a problem to solve with the quadratic formula because you would be asked to solve the equation. You could be asked to find the roots of an equation. You could be asked to find the zeros of the function, since you're setting a function equal to 0 to solve it. Or you could be asked for the x-intercepts of the function. All of those mean to do the same thing. There are slightly different versions of it depending on whether you're looking at a graph or solving an equation or talking about a function algebraically, but they all mean to do the same thing. So here's an example of how you would use the quadratic formula. The first thing you should do is pick out a, b, and c. So in this equation, the coefficient of x squared is 1. The coefficient of the x term is -5, and the constant is -14. And I would suggest writing them down somewhere. So here they are written down. Then you want to plug it into -b plus or minus the square root of b squared minus 4ac all over 2a. So -b is the opposite of b. The opposite of -5 is +5. Plus or minus the square root of b squared is 25 minus 4 times a times c gives you plus 4 times 14, which is 56. That's how they got the 81 here. The square root of 81 then is 9. And remember, we're looking for two solutions, so we have both the positive and the negative 9. Add 5 and 9, you get 14 divided by 2 is 7. 5 minus 9 is -4 divided by 2 is -2. And those are your two solutions. And then you should check in the original equation to make sure that they both work. Here's a second example. The quadratic formula, we're solving for x, -b plus or minus the square root of b squared minus 4ac all over 2a. We're going to pick out a equals 4, b equals -5, and then we need to remember that this is supposed to equal 0, so we want to rewrite it as 4x squared minus 5x minus 2 equals 0, and then we can see that c is -2. So then we go ahead and solve. X equals the opposite of b, which is now +5, plus or minus the square root of b squared is 25. Be careful putting that into your calculator. Minus 4 times a times c all over 2a. And then we end up with 5 plus or minus the square root of 25 plus 32 over 8, which simplifies to 5 plus or minus the square root of 57 over 8. We're going to do this one the same way. It's already equal to 0, so all we have to do is pick out a, b, and c, and then put it into the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. That equals 4 plus or minus the square root of 8 over 4. Now notice in this case we can't just stop here, we need to simplify. We need to keep going because we end up with 4 plus or minus 2 square roots of 2 over 4. And further, that becomes 2, 4 plus or minus the square root of 2 over 4, which is, oops, it's a 2. Which is 2 plus or minus the square root of 2 over 2. All right, and then let's do this one last example. X squared plus 3x minus 3 equals 0. Oops, plus 3. So A equals 1, B equals 3, C equals 3. And then we get x equals, notice they're still always solving for x. When we do that on this one though, inside the radical we have 9 minus 12. And we end up with a square root of a negative number. It's okay to have imaginary solutions for these. This is going to give us negative 3 plus or minus I square root of 3 over 2. So go back, review those examples, make sure you understand the mechanics of how to solve. Be particularly careful when you're solving on the b squared part of it, that you put that in correctly, that it's always positive. I'm not going to go through this slide, but you should check in your book or review this slide. This is where the quadratic formula comes from. It's done by completing the square. Right at this point, we moved the constant to the other side and then divided the b term by 2 and squared it, adding that to both sides. So review that, make sure you understand it. You don't need to be able to generate it each time, but you should understand where the formula came from. Sometimes we don't want to go ahead and solve, we just want to know what kinds of solutions we should expect. To do that, you can look at the discriminant. The discriminant is just the b squared minus 4ac part of the quadratic formula. And if you look at the discriminant, it can tell you what to expect in terms of roots. For example, we'll start at the bottom. If b squared minus 4ac is negative, if it's less than 0, then you're going to be taking the square root of a negative number. So your answers are going to be complex. You're going to have answers with an imaginary part. The graph of that would look like this, or it could look like a parabola that is completely below the axis, but it's never going to intersect the x-axis because it doesn't have any real solutions. It doesn't cross that axis. If the discriminant equals 0, if it's exactly equal to 0, then you're only going to get one real rational root. That's because the square root part of this goes away and you end up with simply negative b over 2a. So that's, then you have the plus or minus 0 part at the discriminant, which doesn't matter, so you're not going to worry about it. And then notice that that's how you get the intercept also to be the vertex. That negative b over 2a is the x-coordinate of the vertex when you are looking for, when you have it in standard form. So at that point, the vertex is the same thing as the intercept. You get one real rational root. If the discriminant is positive, if it's greater than 0, that means that the parabola crosses the x-axis twice and you get two solutions. If what's under the radical is a perfect square, like 81, like in our first example, then we're going to end up with rational roots, with roots that can be written as fractions. If it's not a perfect square, like 82, then you end up with irrational roots. If they were rational roots, then you might notice you could have factored in order to get the solution. If it's irrational, then you know you're going to have to go ahead and use the quadratic formula. Finally, you might think, well, how should I choose what to use? We now have all sorts of different solving methods. You can solve by graphing, excellent if you've got the calculator, not so great if not. You can factor, that's something that you've been able to do since Algebra 1. You should factor if you can factor, especially if the constant term is 0, because then you can just do a greatest common factor, like in this case x times x minus 3, and get your two solutions. Completing the square and quadratic formula, those always work, but sometimes they're kind of cumbersome to use, so it might be easier to look for an easier method. But if you had to pick just one method, you could always complete the square, you can always use the quadratic formula. You can choose which one you prefer. I wouldn't choose completing the square if the b coefficient is an odd coefficient or if it's a fraction. Square root property is nice when things are already written like this, but I'm not sure I'd use it other times, but it's up to you. It's kind of on the way to getting it to be completing the square. You should be able to do all the methods, and you should be able to pick whichever method works best for you for a given problem. So we know you can always put them in the calculator and graph, so we're not going to offer that as an option for these, but on this one, completing the square. All methods work, but completing the square would be particularly easy on this one because a is 1, the coefficient of the x squared term here is 1, and because the b term is even. Quadratic formula also would work on this one. It always works and it's not so bad. You can't factor, and it's not set up to do the square root property right away. In this one, it's in vertex form, so square root property is going to be easy to do. You simply add 2 to both sides. And then divide by 3. And then you have x minus 1 squared equals 2/3. And then you can just take the square root of both sides. Quadratic formula would work, but in order to use it, you'd have to multiply it all out. So I wouldn't recommend using quadratic formula. It's a lot more work. Completing the square isn't going to be helpful because it's already completed. And with factoring, again, you're going to have to multiply it all out and then see if it factors. Maybe it does, maybe it doesn't. So I wouldn't recommend either one of those. For this one, it looks like it's ready to go, except that note it equals 10, not 0. So the only thing you can really do on this one is multiply this out using FOIL, and then subtract 10 from both sides, and then see what you've got. If it factors nicely, you can factor. If it doesn't, use the quadratic formula, or you could also complete the square. That always works. You just have to assess what the thing looks like when you're done. If it's got an a equals 1, if the first coefficient is 1 and b is even, then go ahead and complete the square on that if you'd like. Okay, here's some ones for you to look at. Determine the best method for solving each one of these. You have your choice of factoring, taking square roots, completing the square, or quadratic formula. And we'll work on these further in class, but you might want to think about it ahead of time and see what you think would be the best method. And then here's some more for you to choose. We're going to go ahead and solve these. If you want to go ahead and try a couple, note that we want you to find the exact solutions. We do not want you putting these in the calculator and getting 1.234 whatever. We want the exact answer with the square roots and everything. Finally, think about what questions you want to ask in class. What's still unclear? Come prepared with a couple of questions to ask.